Good morning, cadets. Let us solve some numerical problems on the combination of the cells, right? The problem is like this. It is a problem of charging of a battery. A storage battery of EMF 8 volt having internal resistance 0.5 ohm is being charged by 120 volt DC supply using a series resistor of 15.5 ohm. So, I will just draw the simple circuit diagram. This is a storage battery of EMF 8 volt. This is being charged by using 120 volt battery. Symbolically, I am just drawing 120 volt battery, right? 120 volt battery. This is being charged. So, remember, while charging, the positive terminal of the charging battery, positive terminal of the supply is connected to the positive terminal of the battery which is to be charged, and negative terminal is connected to negative through a series resistor. A series resistor is being used whose value is 15.5 ohm. A series resistor of 15.5 ohm, and this is a cell of internal resistance small r equal to 0.5 ohm. This is how a circuit is being drawn. Question is, what is the terminal voltage of the battery during charging? During charging process, what is the terminal voltage of the battery? And what is the purpose of using a series resistor in the charging circuit? Now, remember, while charging, positive terminal of the charging unit is connected to the positive terminal of the battery to be charged. See here, this is negative terminal, this is positive terminal, and negative terminal of the charging supply is connected to the negative terminal, so that the current is delivered from this battery of EMF E1 into the battery of EMF E2. The current is supplied into the battery of EMF E2 which needs to be charged. Charging process means actually a reversible chemical reaction is going to be set up. The chemical reaction is done in a reversible order. When the reaction is done in the reversible order, then what happens? The battery gets charged up, and again that battery can be reused. This is called as charging. So, E1 is 120 volt, E2 is 8 volt, and internal resistance of this battery is 0.5 ohm, and a series resistor is taken which is of 15.5 ohm. You are asked to find out what is the terminal potential difference or terminal voltage of the battery. So, first let us find out the current. So, the current in the circuit, as I have shown here, the current in the circuit will be flowing in this fashion from the positive terminal to the negative terminal. So, you can see here the current in the battery is entering inwards from positive towards negative. Therefore, it is in the reverse order. So, E2 will be taken negative. So, the current I is equal to net EMF divided by external resistance plus the internal resistance R. First, what is net EMF? Since here the current is in the reverse order for the second storage battery here, so it becomes E1 minus E2 divided by R plus R. What is E1 here? E1 is given 120. 120 I have written here. E1 is 120 and E2 is 8 volts divided by external resistance is 15.5 and internal resistance is 0.5. So this becomes very simple, 112 divided by 16. 112 divided by 16 gives us the current I equal to 16 sevens are 7 ampere. So current becomes 7 ampere. Okay. When the current becomes 7 ampere, right? Now we shall solve for the terminal potential difference. To solve for the terminal potential difference, terminal voltage or terminal potential difference across cell of EMF E2, right? So if you call it as V is equal to E2 minus IR, but since the current is in the reverse order, so it becomes E2 plus IR. You can see here, current is from positive terminal to negative terminal. It is from P to N even inside. Therefore, it is taken as minus of minus, that is plus. Therefore, E2 plus IR. And thus, if you substitute 8 volts, E2 is 8 volts plus I just now we have found out 7 into internal resistance is 0.5. 0.5. So it becomes 8 plus half of 7, 3.5. 8 plus 3.5. Thus terminal potential difference becomes 11.5 volt. So in this example of charging, the terminal potential difference across the cell, across the battery which is getting charged will be more than the EMF. This is the special case. Please remember, when the current direction is reversed, while charging the current direction is reversed inside, the current direction will be taken negative, I will be taken negative. So as a result, what happens? The terminal potential difference becomes E2 plus IR. So thus it becomes 11.5, which will be greater than EMF. This is the special case. Okay. Then second one, what is the purpose of having a series resistor in the circuit? What is the purpose of having series resistor 15.5 or any other value? If the series resistor is not taken, then what happens? This is the first part. Second part, if R is not taken, if R is not taken means, suppose if R is 0, then what happens? The current becomes infinitely high. I becomes dangerously high. What will be the value of I? Just calculate. I becomes, you see, 112 net EMF divided by, if R is 0, 112 divided by R is 0, then what happens? It is just internal resistance 0.5. So 112 divided by 0.5 becomes 224 ampere. That is, I max becomes 224 ampere, which is dangerously high, infinitely high and dangerous. As a result, what happens? This cell will be totally spoiled. This battery will be totally burnt. So it will be undergoing breakdown. Okay. This is the reason why a series resistor is always taken, so that after taking series resistor, you can see the current is limited. The current is limited. So by taking series resistor of certain value, the current is minimized or current is limited. When the current is limited, then the circuit is safe and the storage battery is also safe. That is the purpose of taking series resistor. Okay, this is application based problem. Okay, now let us solve one more problem. Let us look at this interesting problem. Determine the current drawn from 12 volt supply with internal resistance of 0.5 ohm by the infinite ladder network. Infinite network that is shown below here. This is called ladder network. Each resistor has a 1 ohm resistance. Look at this. This is a continuous circuit. I have shown here with a dotted line. The continuous circuit has a repetition of the pattern. It has a repetition of the pattern. As you can see here, the pattern is repeated 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1 ohm, 1. All these resistors are of same 1 ohm each. They are repeated and the one free ends of these two are connected to a battery of 12 volt EMF having 0.5 ohm internal resistance. You are asked to find out what is the current through this network. This is infinitely extended. So, such a network is called ladder network, infinite ladder network. So, for this what we will assume? Let us assume that the equivalent resistance of the entire network, let us take it as X. Let X be the equivalent resistance of the entire infinite ladder network, as I have written here. This X is, let me take this X up to here, or the entire network, if you have taken it as X itself, there is no harm if you just add one more same pattern. Suppose I am adding just one more same pattern of 1 ohm and 1 ohm here and 1 ohm here, and connecting it to the terminals of the battery, which is having small internal resistance R. R is equal to 0.5, E is equal to 12 volts. Same thing, means you can imagine these are the two terminals AB. From here to here I have taken X, okay, and this is the remaining pattern. Altogether it is X itself. Let X be the equivalent resistance of the entire infinite network. And even if you add one more pattern or two more such repetitions, it will not increase. It will not increase. Already it is having infinite ladder network, right? Therefore, if this is taken as X, then I can find out what is the equation for infinite ladder network, equation for equivalent resistance. Suppose X and 1 are taken like this, X and 1 now they are in parallel, X ohm, 1 ohm, they are in parallel, so that this can be first found out as X into 1 divided by, see here, they are in parallel, X into 1 divided by X plus 1, right? X into 1 divided by X plus 1, it is just like R1 R2 divided by R1 plus R2. So, X into 1 divided by X plus 1, remaining 2 ohms are there, 1 ohm and 1 ohm each, they are in series, therefore it becomes 2. So, X divided by X plus 1 plus 2 should be equal to X itself, since we have assumed that X is the equivalent resistance of the infinite network, right? So, now I am going to draw the equivalent circuit diagram, same one. So, I am just drawing here, yes, this is X upon X plus 1, this is 1 and this is 1, and these are now connected to 120 volt 12 volt battery, 12 volt battery having internal resistance 1.5 ohm, 0.5 ohm, E equal to 12 volt. Same diagram I have drawn, equivalent diagram. So this is 1 ohm, this is 1 ohm, and this is x by x plus 1, right? X into 1 becomes x, x by x plus 1. Now we will solve for x. Again it is a algebraic equation. When you solve for x, you see x divided by x plus 1 plus 2 is equal to x. Okay, I will take it as x divided by x plus 1 plus 2 equal to x. Therefore, on simplification, x plus 2 x plus 1 divided by x plus 1 is equal to x. So, take it to the right hand side. So, it becomes x plus 2x plus 2 whole divided by, okay, this I am taking it to the right hand side. So, it becomes x into x plus 1, x square plus x. Now, it is a simple equation. You can solve it for x using a quadratic equation. It becomes quadratic equation. X plus x, x plus 2x becomes 3x, 3x minus x becomes 2x. Therefore, x square minus 2x minus 2 becomes 0. This is the quadratic equation which can be solved for x. So, x has the roots minus b plus or minus square root of b square minus 4ac. It is of the form of ax square plus bx plus c equal to 0 divided by 2a. Now, just substitute the value of a, b and c, you will get the result. So, minus of minus plus 2 plus or minus square root of b square becomes 4, 4 minus of minus plus 4 to the 8, right, divided by 2 into a, that is 2. Yes, sir. Now we can solve for x. So this, if you look at it, x becomes 2 by 2, that is 1, x equal to 1 plus or minus root 12. Root 12 becomes 2 root 3. 2 root 3 divided by 2. 2 root 3 divided by 2 becomes root 3 itself. Okay, 1 plus root 3 and 1 minus root 3. So, in this 1 minus root 3 is ruled out. Therefore, x is equal to 1 plus root 3 is the solution. 1 minus root 3 becomes negative value cannot be the solution. Now, if you get the value of x, now we can very easily calculate what is the current. Therefore, you can see the equivalent resistance x of the infinite ladder becomes 2.7 ohm, right? Therefore, R equivalent, which we have assumed as x, it becomes 2.7 ohm. 1 plus root 3. Root 3 value you have taken it as 1.71. So, up to first decimal if you take, it is 1.7 plus 1, 2.7 ohm. Now, I can calculate what is the current. Current I is equal to E divided by R plus internal resistance small r. E is 12 divided by R is 2.7 plus small r is 0.5. Yes, 0.5. So, therefore, it becomes I is equal to 12 divided by 3.2. 3.2, if you just take the decimal, it becomes 32, right? 8 4s are 8 15s are 8 4s are 8 15s are, right? 15 by 4. So, that gives us the current. Therefore, current value becomes 4 1s are 4, 3s are 12, 4 3s are 12, 3 remains, 4 7s are 28, 5, 4 5s are 20. So current becomes 3.75 ampere. 3.75 ampere. This is how one can calculate current. Even if you want, you can calculate the terminal potential difference. In this case, terminal potential difference will be less than the EMF. V equal to E minus IR. E minus IR. Okay, because already we know what is I, 3.7. We can calculate V. V equal to E minus IR, that is the terminal potential difference. 12 minus 3.7 into 0.5. So that becomes half of 3.7. Half of 3.7 is 1.95, 1.85. So if you take it as 1.9, then you can see here the terminal potential difference is less than the EMF. Hardly, it is about 10. So 10.1 volts. 10.1 volts. So that's how terminal potential difference will be always less than the EMF of the cell. Now let me solve one more problem. So look at this problem. There are two cells which are identical in all respects. Two identical cells, when they are connected either in series or in parallel combination, the combination gives the same current 0.5 ampere through an external resistance 4 ohm. Find the EMF and the internal resistance of each cell. This is an interesting problem. So first I will draw the cells symbolically. Two cells of identical nature, both having EMF E and internal resistance R, connected in series. Now connected to a series resistor which is given here, resistance R, which is equal to 4 ohm. They gave the same current. The current will be from the positive terminal, you can see here. So same current I, which is 0.5. This is for a series combination. When the same cells are in parallel, right? When they are in parallel, same identical cells, right? They are sending the current in the same direction, positive, positive, negative, negative. This is also EMF E and EMF E. Internal resistance R, internal resistance R. They are sending the current, combined current. Combination gives you same current I, that is passing through a series resistor R, which is equal to 4 ohm, and the value of current is same. I is equal to 0.5 ampere. So if this is the case, you are asked to find out what is the EMF of each cell and what is the resistance of each cell. This is the question. So now we will solve it step by step, applying the theory of series and parallel combination. Let us consider for series combination. For series combination, terminal potential difference V equal to E effective minus I into R effective, right? Equation is same for both. So what is E effective when they are in series? Look at this. These two are in series. So E plus E, it becomes 2E minus R. Internal resistance R plus R, R1 plus R2, it becomes 2R. So R plus R, 2R. Therefore, it becomes 2 into bracket E minus IR. This is terminal potential difference V. Call this equation 1. Here value of I is given, that we shall use it later. Value of I is also given, and yes, only I is given, and external resistance R is given, right? External resistance R is given. Here I is equal to 0.5 ampere, external resistance R is equal to 4 ohm. These are the given things. Now for parallel combination, in the same way, for parallel combination, yes, V becomes equal to same E effective minus I into R effective. Here, let me first find out what is E effective for parallel combination. We know that E effective for parallel combination is given by E1 R2 plus E2 R1 divided by R1 plus R2. This is what we have done in the previous session. We have already derived this. So, R1 and R2 are same here. R1 is equal to R2 equal to R. Therefore, E1 and E2 are also same. So, it becomes ER plus ER. 2ER divided by R plus R. You can see here. R plus R. R plus R is 2R. So, 2R cancels. After cancelling, the effective EMF just becomes E itself. Very interesting. Effective EMF just becomes E itself. Then R effective can also be found out. R effective is equal to R1 R2 by R1 plus R2. So, both the values are same here. So, R into R becomes R square divided by R plus R, 2R. So, 1 R cancels. Therefore, R effective in this case becomes 1 R cancels, R by 2. Substitute in this equation, we will get the second equation. Substituting in the above equation, we get, therefore, V equal to E effective is E minus I into R by 2, I into R by 2. So, this is second equation. This is second equation. Now, we can find out what is terminal potential difference V. See, equating 1 and 2, we get the equation for E and R respectively. We will get the values of E and R. Now, we know what is V. Terminal potential difference V is also equal to Ri, the current through the resistance. In both the cases, it is same terminal potential difference, 4 into 0.5 Ri, 4 into 0.5. 4 into 0.5 becomes 2 volt. So, terminal potential difference is 2 volt. So, E into IR by 2 equal to 2 volt. 2 times E minus IR is also equal to 2 volts. This is how we get the equation. We can solve for R and we can solve for E. Therefore, now equation 2. First I will write what is equation 2. Equation 2 is equal to 2E minus IR by 2. So, this can be written as, this is equation 2, this can be written as 2 times V equal to 2E minus IR. So, this you can make it as modified equation. 2V minus 2E minus IR. I think you got it. 2E minus IR divided by 2. So, this 2 is taken here. So, it becomes 2V minus 2E minus IR. So, what is equation number 1? You just write it. 2V, it is just V equal to 2 into, I will write it as 2E minus 2IR, 2E minus 2IR. Yes, now I can solve it. Just subtracting 1 by 2. Subtracting equation 1 from equation 2, we get the equation for R and I, right? 2E cancels. Now substitute the value of V here. V is 2 volts. Subtracting 1 from 2, we get 2V equal to 2E minus IR, 2E minus IR, and here V equal to 2E minus 2IR. So subtracting these two, we get, yes, 2V minus V equal to V, 2E cancels. So you are left with 2IR minus IR becomes IR. So V is equal to IR. V is already known to us and I is also known to us. Therefore, small r is equal to V by I. We have found out 2 volt. 2 volt divided by current. Current is 0.5. Current is 0.5. So thus it becomes 2 by half. It becomes 4 ohm. Therefore, R is equal to 4 ohm. Now you got the internal resistance. Internal resistance of each cell. Therefore, internal resistance of each cell is equal to R is equal to 4 ohm. Now, what is the EMF E? We can substitute the value of current and resistance R in either of these equations. Let us say second equation. We have V equal to, okay, first equation, second equation, 2V. Second equation, 2V equal to 2E minus IR. So that I can get the value of E. V is equal to 2. We know it is 2 volt. So 2 into 2, 4 equal to 2 into E minus I is 0.5. IR is already V, that is 2 into 4. So that 4 equal to 2E minus half of 4 becomes 2. Therefore, if you take it this side, then it becomes 4 plus 2 equal to 2E. This implies EMF of each cell is 6 by 2, that is 3 volt. Therefore, EMF of each cell is 3 volts. E equal to 3 volts. So this is how we need to solve the numerical problems. So I think I have solved enough number of numericals. So from the next video onwards, we will start discussing complex electrical circuits, in which we are going to use important laws. They are called as Kirchhoff's laws. So we are going to learn Kirchhoff's laws. Using Kirchhoff's laws, we can solve complex electrical circuits. Okay. Thank you. Have a nice day.